Hello everyone. Today I Amit Patel is going to share with you my experience and the things that I have done in my summer internship project with Converge AI in association with Bennett University and JHRC College, Rice Uni. So my mentors are Dr. Vipul Kumar Mishra from Bennett University, Mr. Ketan Patnaikar, co-founder and CTO at Converge AI, and Dr. Gopal Sakarkar from GHRCE College. So these all are the organizations that are involved in this project, that is Converge AI, Bennett University, and GHRC College. So my project was natural language based nano BERT. Basically, I have trained a BERT model for medical corpus, and the corpus was I'll explain you in next slides. So building a language model BERT from scratch on custom data set was our ultimate goal. So these are the content of my presentation, what I'm going to present. So the first page would be abstraction of project. The second page would be language and what are the resources, softwares that we have used, and the main focus is on hardware because we have used NVIDIA DGX for our model training. So it was a very nice experience using that. And the other thing that are the part of this presentation are steps involved in project, that is data collection, training a BP tokenizer, training our language model, that is BERT from scratch, testing our language model. These are all the steps that are involved in our project. So before diving deep into what I'm going to share with you, uh, I must say everyone who is seeing this presentation or who is watching this video should basically visit my code at this link so you can get more insight into my project easily, because code speaks more than presentations, I guess. So the abstraction of my project is basically bidirectional encoder representation from transformers, that is commonly known as word for NLP, was originally published by Google in 2018. So there are a lot of language means models available, means for example now GPT is the most advanced one, means the most recent one model. So uh, basically our task in this project was just to train a BERT from scratch. Here we are not talking about fine tuning of BERT or something. We are talking about training of BERT from scratch uh, on a custom corpus of data that we have collected from a famous textbook of medicine, that is Harrison's Principle of Internal Medicine. It's considered as the Bible of medicine by medical professionals. So we took that as the corpus, that the raw source of data that we will be using. So next, what are the softwares, as this is a AI task, means NLP task. So Python, MLflow, Databricks, AWS, three buckets for storage, Anaconda, Jupyter Notebook, Google Collaboratory, and Kaggle kernels. All these are the things that commonly data scientists and commonly the people who are involved in AI use often. So basically, what is DGX, and about DGX1 V100 that we use. DGX1 V100 is an on-premise Bennett University's basically supercomputer that most of the faculty, researchers, and students uses in our university to do this computationally heavy tasks. So talking about what is DGX is, and so about DGX 1 V100, the DGX 1 is a deep learning system architecture for high throughput and high interconnect bandwidth to maximize neural network training performances. The NVIDIA DGX1 V100 is the first system built with groundbreaking NVIDIA Pascal powered Tesla cores. V100 accelerators means these Tesla V100 accelerators are basically graphic cards that we use in DGX. I must means I know most of the people are aware of that this thing. Um So basically, DGX is the world's first purpose-built system for deep learning and accelerated analytics tools and everything. If we talk about the architecture of DGX, so the core of the system is a complex of 8 Tesla V100 GPUs connected in hybrid cubicle mesh and NVLink network topology. And in addition to the 8 GPUs, DGX1 includes 2 CPUs for booting, storage management, and deep learning framework coordinations. All right. So if we talk about performance and ease of use, it delivers performance equals to 500 conventional servers like that. So these are the resources that we have used. So now onwards we will talk about the steps that were involved in project. So let's dive deep into the project. So this presentation is basically my experience building a language model from scratch on DGX, highlighting four main steps covering data collection, that covers data collection, training BP tokenizer, training the language model from scratch, and testing the language model to set up a full-fledged baseline for our project, right? So the data collection step is the very first step to building a language model, and is to collect large corpus of. In this step, we just wanted to collect large corpus of text data from a textbook called Harrison, which is actually a PDF. So we actually I wrote a script to extract the raw data from PDF to a text file, right? And after that we uh, use that text file to train in training of BPE tokenizer. So here the goal is to build two files, that is vocab.json and merge.txt. The vocab.json is a list of the top key tokens found in the text corpus. Since we are building a byte pair encoding, BP stands for byte pair encoding tokenizer. The merge.txt allows us to perform subword tokenization on our input text. We would be using tokenizer from the Hugging Face library. Basically, is actually a part of PyTorch as shown in my code also, and you can check it out on my code, right? So training our model, now that we have our trained tokenizer and vocabulary, we are ready to start training our language model. There are two steps: loading a data set, setting our model, and training configuration. So you know, we loaded the dependencies, then uh, we created a data set class just to adjust the data in a way so that it can be fed to our model. So configuring our language model and training is one of the crucial steps. We need to configure two things: our language model architecture, in this case we use Roberta, and training settings, hyperparameter and everything we have to tweak. In the experimentation part, here is the thing that we experimenting, means we did the experiment on this portion only. Initializing and training language model, as we did, once we have the configurations and everything set it up, we can use those to initialize our language model Roberta and our trainer. Then the last phase of our project is to testing our language model. Once we have trained and save our language model, we can use it to predict the next token in sequence, or directly return the score or some on some testing data set. But actually what we did is we created a UI kind of thing, just a question answering session type of thing, where you can enter some kind of question, and the word using that BERT model, the API will return you something related to, means the most relevant answer to that question. So this is my summer internship project that I did with Converge AI, Bennett University, and JHRC. And I would really like to thank these mentors, Vipul Kumar Mishra sir, Gopal Sarkar sir, and Ketan sir for constant support. And I really appreciate my the contribution of my team members from both the organization. So that's all for this presentation. Thank you.